Hi, and thanks for taking the time to watch my video. You know, when I heard that a bunch of smartwatches were coming out, I got really excited because as a hobbyist, I've always wanted to have a small wearable computer with a halfway decent display and a bunch of sensor inputs that I could program and I could customize, not something that I just needed to buy off the shelf and then download things from an app store or be hitched up to a company who tells me here's how your display is going to look. And I really wanted something you could customize. And when these smartwatches came out, I got really excited thinking, wow, somebody's going to do that. And much to my despair, nobody's done that. The smartwatches that have come out are these beautiful pieces of jewelry that are linked to a phone, and they're really just used as an alternate display for a phone. And even the so-called open source watches that have come out are really just kind of dumb receptors, displayers, and then they'll give button pushbacks. So you're really working through the software development kit of the watch itself to just send it messages and tell it to do things. It's truly not a customizable standalone system. And searching the internet for a long time and just hoping and waiting and just never seen it come to fruition. And I can't believe I'm the only one out there, the only hobbyist that would want a good looking watch that was completely customizable. And when you talk about completely customizable, it's easy to see how Arduino would suddenly be at the center of that project. Arduino is so well supported by community. It's so easy to get into, it's so easy to program, so many tools are available, so many options for you, and as far as an open source project, it would just be an amazingly popular thing as a hobbyist project that could be pushed through. So knowing that didn't exist and seeing that Atmel had an AVR contest, a little 8-bit contest, I thought, you know what, that would be the project that Atmel should jump on. That would be the thing that they could do better than anybody else. Atmel's been supplying their chips to Arduino since inception because they're great chips and they're robust and there's lots of support for them. There's lots of history and lots of open source tools that you can use to program them. And that kind of sets Atmel apart from a lot of other competitors where their things are just too hard to program, or you have to buy expensive software in order to be able to program the chips. So I figured if I could hobble together a working system to kind of do a proof of concept and to see, would this look cool? Would this be something that would be interesting? I think it would be an easy place to start. There's a lot of work that would still need to be done, but thanks to a lot of these breakout boards from companies where you can try the different sensors and things like that, a lot of the work's been done for me. So let's go a little bit into the hardware that I have. The first and most obvious thing, the typical 1306 OLED display. It's 128 by 64 pixel. It's a great little display. It runs on I2C, so very little overhead. This particular display really only has power, ground, and the two I2C input and output pins. So incredibly low overhead. Operating right now is probably only drawing 5 milliamps. That's phenomenal for an active display. I don't need a backlight because these are OLEDs. They're emitting that light. So that's a huge advantage, not having to run a backlight. But what I have in my software right now is I can actually go into a sleep mode so that I'll even conserve that. And if you could shut down all the peripherals because of the low operating current of Atmel's 328, Mega 328, you'd be down in the microamp level while this watch is just sitting on your wrist. So pretty extraordinary. What I have furthest to the left is I have a BMP 085 pressure temperature sensor on a breakout board. Really nice sensor, gives you temperature, pressure, compensated pressure, and then temperature in the process. Really nice chip. I have the OLED display. Like I said before, that would be the main display of your watch. You could probably add another LED for alerts and things like that. I don't have that currently, but that would be another really great thing to add. You got plenty of room still on this AVR chip. You have the Atmel Mega 328P, the typical Arduino Uno, but I've loaded it with a bootloader for the Mini Pro 328. And what that allows me to do is, rather than use a 20 meg crystal on the input to the chip, I can use a clock crystal, a regular 32K, and I can leave the microprocessor running on its internal oscillator at 8 megahertz, and I can use this external oscillator input to run a real-time clock by using the clock crystal. That's a really flexible, amazing thing about this chip, is it can be its own real-time clock, and it really draws very little overhead to the processor. I have an interrupt service routine that whenever the counter falls over, it starts this interrupt service routine. I come out of sleep, I add 8 seconds to my clock's time, I update my variables for seconds, minutes, and hours, and I go back to sleep. It takes no time whatsoever. That's why you can be down in the very, very low microamp range when this thing is just in sleep mode. It's amazingly impressive. I have 2 buttons here, and one I'm using as a mode switch and a wake up switch. That one is attached to an interrupt input, so once this chip goes to sleep, I can wake it up by energizing that interrupt by just giving it a shot. Right now the software is set up that if you get 1 shot on the mode button, the time will come up for about 2.5 seconds and then go back out. And that's a typical watch function. I just want to know what time it is, I hit the button, it tells me, and then it drops back out to save power. If I want to keep the watch up while it's displaying the time, if I hit mode again, I'll go into this menu. And the menu is what's going to select the different functions, the different apps, if you'd like, for this watch. The other button I have is just a general purpose input output. It's hooked up on an interrupt right now, but I don't have it interrupting. I just pull it whenever I need to. And this, in this case, will cycle through the different modes. So if I select clock and select it, it'll actually leave the clock on until I go back into the sleep mode. Right next to my buttons, I have a 3-axis accelerometer. That's an MMA 7361. Really good, really simple, nicely configurable. And up here, I just 3.3 low voltage dropout regulator so that I can power everything. I have a 3.7 volt lithium ion battery, and then probably most people, anybody in the hobby industry, will recognize the little HC06 Bluetooth dongle over here. So one of the things that would definitely be important to minimize the power, right now I don't have any switching on the peripherals or on the Bluetooth. So right now I'm probably drawing about 40 milliamps. That's way too much for just a watch sitting around showing time. So you'd want one of the outputs, or probably 2, of the Atmel Mega chip to go through maybe some JFETs and have a peripheral power bus that you'd put your sensors on, and then a Bluetooth power bus, so that you could actually keep those things totally de-energized until you needed them, and then you'd kick them on, do what you needed to do, and kick them off again. And all that would conserve a dramatic amount of power. So that stuff is still left to be done. So remembering that the mode switch brings me up, brings me to the menu, and cycles through, I'm going to zoom in now on the display just so you can see how some of this stuff can operate together. So like we were discussing, the watch operates through a mode switch and a secondary switch that'll cycle through options and could be anything else. What I envision for a final product would be one of those thumb rocker switches where you can rock up, rock down, and press in. So the press in would be the mode, and the rock up and down would be selectors, either going up and down menus or selections or whatever you needed to. So right now I'm in the clock mode. I'll get out of that with one push of the mode button. This would be the sleep mode that should be in. 2 clicks get you into the menu, and the clock would be the first one. So my first selection that I rotate through is weather. I call it weather, but really it's just temperature and pressure. So this is the information that's coming from the BMP85, and it's sitting right over here. Now you see the temperature. If I put my finger on the sensor, I can get the temperature to go way up. So you think about that. If I had a watch, standalone system that I could program, and I had access to temperature and pressure data, what could I do with it? Well, obviously the first things like I did is just display them for curiosity or for taking information, taking data on something. Second is the pressure could be converted to altitude. So I now have a working altimeter, which might be really useful if I go hiking. I could write a program to track the altitude, track the rate of altitude, ascent or descent. I could set alarms depending if I exceed some parameter there. I can track the temperature and pressure over time and use those to give some kind of foresight into changing weather. You can start really thinking about, boy, there's a lot of apps that you could develop just with that sensor alone. So one click gets you out of it, put you back into sleep mode, and get you back up. And the accelerometer package, there's another one. Using the accelerometer, I can tilt this and show you. I can go negative in the X, and negative in the Y. And I'm not going to play with the Z because I'd have to go up and down a lot. But having that three-dimensional acceleration suddenly becomes huge. Not just for the normal things that you would expect. Like, yeah, I can do the pedometer. I could write myself a pedometer app. I could also do gesture-based programming to where when I move my wrist up, the time comes on. But you can expand it to even further. Like, how about an alarm system, where if I set the watch down and I put it into this mode, it allows 3 seconds of stabilization, and then it takes the X, Y, and Z values and creates little windows for them. And if those values go outside the windows, they'll kick off an alarm. So many other things. And once you put that kind of power out into the hands of hobbyists, they're going to go crazy with what they can do with just some simple sensors. So again, one click gets you back into sleep. Call up the time, call up the menu. Got to be able to set the time. So that's one of the things I threw in there. We'll call it 11:48. And what I did is on the done, I actually would wait there until I saw time roll over, and then I'd select it. Because when you hit done and exit that mode, I actually set the seconds to 0. So it's a way to sync your clock with some other timepiece, so you can get some really accurate time because of that. And I've been amazed at how little drift there is at the real-time clock generated by the Atmel chip itself. The last thing I have programmed in to give you just a look at some Bluetooth connectivity, here in the Bluetooth section, all it comes up says Bluetooth, and it says enter T for time. I'm going to go over to my computer and show you that if I sync up Bluetooth with this device and I send it a T, it will send me back the time. So right now I just have a Bluetooth serial terminal up. I've connected it with my Bluetooth board, and like I said, if you send the board a T, you get back the time. It says 11:50. So this just shows you a really simple two-way communication on Bluetooth that would suddenly open up this watch to the rest of the world. There are really, really cheap Bluetooth GPS systems, so that would be an easy way to get GPS into the watch without actually having to put a GPS receiver in there, which would be a large volume and a pretty high energy load. Bluetooth would open you up to a lot of different things, potentially interfacing with headphones, definitely interfacing with cellular phones, which then opens you up to being able to get information from the internet and all the other things that the connected watches do right now. You can have software that would tell you when someone calls, send you the name to the watch, and that would be all relatively simple to program. So just a little sample of the functionality there, but Bluetooth I think would be really important, because without having a lot of expansion ports for this watch, you would definitely want to have some way to generically interface to the outside world, and Bluetooth is such a great tool for that. Thanks so much for listening and watching the video. If you're interested, please go to Atmel's site or follow the link below and vote. There's some amazing projects as a part of this contest, and if you like this idea and you're a hobbyist and you want a watch like this, but you want it done professionally, go ahead and vote, because I really want to convince Atmel that they should be the ones to take on a project like this as a development platform. They would just do this so right, and it would be robust, and it would work great, and it would interface wonderful. So hobble over to that site and vote for this project, and let's see if we can make it happen. Thanks.